Secretary, data scientist, and member of the Machine Learning in Reserving Working Party. I'm making this recording to show people how to make a local copy of the code that enables you to build reserving models using neural networks and gated recurrent unit neural networks, sequence neural networks. Background to this is the recent work of the wider Working Party, in particular the work of Jacky, David and Sarah McDonald, all of whom have shown how to use neural networks, feed-forward neural networks for Jacky and David to do the equivalent of chain ladder reserving. And Sarah's used time sequence neural networks, GRUs. Now, back in November, I reached out to Sarah to explore how I could get back into the Working Party and contribute meaningfully. And after that discussion with Sarah, she felt it might be helpful to enhance the existing notebooks in order to make them more robust, make it easier to interpret and compare the various approaches. And that's something I have experience in my role as Chief Data Scientist in a big insurance company, creating ML software and building full cycle products. And I've started the journey of doing that with a GitHub repo, which you can see here on the screen. And so if you would like to join me on the journey of making more robust code, doing the exploration, then please do. This repo is far from perfect, but if we get more people building these things, contributing, then the date at which it becomes more robust will be sooner rather than later. So yeah, this is really a bit of an encouragement for people to get involved and trying to make it easier to do so. So look, I'm going to try and do this in one shot, so therefore I'm likely to deviate, hesitate, and get a bit mixed up. So apologies for that, but hopefully you understand and give me a bit of leeway. Let's get on. Let's go to GitHub and have a look at the code base and see how to install it locally. So I've already got the repo open over here on my screen. Hopefully you're aware of GitHub version control and use it. If you're not, don't worry. It's relatively easy to use, but I would suggest you do a little bit of reading, Googling, and get yourself a login and get used to using it. It's a way of just many things, but it's a way of regularly taking snapshots of your code, and if you develop something and it goes wrong, you can go back and you can fix things. It's really useful if you're working in a collaboration with other people and you want to have multiple people developing code as well. I'm far from an expert in it, but Google is your friend. So this sits on GitHub servers. It's got a lot of folders and code in it. So the main artifacts of this repo are in the code folder. We can have a quick look at them here. You'll see there are some Python notebooks here. This is the gist of the content. And there are some supporting folders that we'll go into in a little bit more detail. So this is the sort of instructions that if you put it's the recipe, let's say, for you to make something. What you've got to do is take that recipe to your own kitchen and cook it in your own oven before you can consume the output, so to speak. So there's the recipe. What we now need to do is make sure on your machines, your local computers, laptops, whatever you're working on, that you have a suitable kitchen and tooling in there. So if you're programming in Python, you need to have Python installed on your machine, and B, need to have some a coding tool, an integrated development environment potentially. And I'm a fan of Positron from Posit. You can again download that for free on the internet. It works with Windows, Mac, and Linux. I prefer to work in Linux, so everything you're seeing here is in Linux. The repo should work in Windows or Mac, but because I have neither of them, I can't confirm that. But it should be possible working in due course. But you'll see me do it in Linux for now. So yes, you want to be able to get to GitHub. You have to have a coding IDE. I would say that Positron is effectively a fork, of VS Code, and many people may be familiar with VS Code. You'll see Positron in a while and see why I like it. I'm not a great fan of developing software in Jupyter Notebooks. I know a lot of people start in Jupyter Notebooks. It's a great place to start, but as soon as things get complicated, the notebooks become limiting. And we are at a stage where things are complicated now. There's a lot of componentry, and that's better coded in a more full IDE and in Python scripts. So you will see back in the repo that there are essentially two suites of code. One of them is the sequence neural networks, the GRUs. One of them is the feed-forward neural networks. Right? And there are 3 files for each of those. There's the original notebooks that created by other working party members, Sarah for the GRU, Jacky and David for the neural network, original ones. Then there are 2 extra ones with my initials in NJC, and these are the ones that I've created that build upon these original ones. The Python notebook is equivalent to the IPy notebook, the Jupyter notebook version. I just prefer to code in Python and then convert it to a notebook. So I've tried to cover all bases. Those that like scripts, those that like notebooks. As we go through this demo, we'll run the notebook version. It's just more visual. Again, I'm digressing, aren't I? So let's open up Positron. I believe I already have it open. Let's see. Yeah. So you start off with Positron, and we need to. Actually, I've done this the wrong way around. Don't start with Positron. We want to start with to create a folder, and we will clone the repository into a folder. So apologies. I need a file browser, file explorer. So here we are in a file explorer. I'm in my home directory, and in fact I'm in the Git folder of my home directory. Now I'm going to create a new folder in here. A new folder. I'm just going to call it demo, and I'm going to pull the repo into there. So there's the demo folder. I'm going to go into it. I'm going to open in terminal, and here I'm going to pull the Git repository. And to do that, clone the Git repository. To do that, it's just the commands git clone. And then we need to know the URL of the repository we want to clone. So we go back to our browser and go there, and we can get it from here. Right, so that's the URL of the repo. Copy that to clipboard, back to my terminal, paste there. So git clone, blah, blah, blah. Press enter, and that will copy the files from the GitHub servers down to the folder on my local PC. The recipe I now have in my kitchen, so to speak. Okay, so what I'm going to do is go into Positron and open up that recipe. Okay, so I am going to go File, Open Folder, and we'll find that home git demo, and we want to go to the root of the code of the cloned folder. So we want to go in here. This will be the root of it, and we just go open. It takes a little while for positron to open things up. We can see the files as we saw them on GitHub. They're now on our local files. And there we go, positron's now open. Now, there are a few things that are important. I have written these notebooks using Python 3.13.11, which is one of the more recent versions of Python at the point I started writing it. I think 3.14 or even 3.15 is around now. But some of the packages we use haven't been updated to work with 3.14, and that's why I'm on 3.13. Okay, so the only guarantee I can give is that this works with 3.13.11. If you've got a different version of Python, I can't guarantee this works. So it would be sensible for you to make sure you have that version of Python available on your system. So you might need to install it. I will have a number of versions of, sorry, I'll try and get to them. I will have a number of versions of Python installed on my machine. Okay, but I'm going to make sure that I'm using Python 3.13.11 because that's what I know this works with. Right? Now, the version of Python is a dependency. An additional dependency are the libraries, Python libraries and resources that we're going to use with this code. It's very important you use specific versions. If you don't use exactly those versions, the code may stop working. So the best way to make sure you're using exactly the same versions as I intended is to set up a virtual environment. And in positron, that's quite simple. And in VS Code, I presume that's fairly similar as well. You want to get to the command, I think it's the command palette, command panel, and it's Control-Shift-P. And you want to find, this is recently used, but you want to find the command Python create environment. Okay, you could start typing in Python, and there are lots of them, but you would find create environment in there somewhere. I've used it recently, so I'm going to click on that, and then you'll have various virtual environments. You may have a choice of virtual environment tools. I'm going to use them. It's available to me. You might have to install it in your Linux distribution to be able to use it. So I'm going to go them. It asks me what version of Python I want to use, so 3.13.11 is important. It's going to ask me, do I have a requirement text folder? And because we are in this working party folder over here, it observes there already is a requirements.txt. So we're going to put a tick there. It will look at the package names and versions in there, and it will put them into a virtual environment. So let's go OK to create that virtual environment. You see in the bottom corner, I don't know if we can show the logs, it's starting to collect all of the packages needed and install them. It installs them in it creates a folder in our file system called .venv, a hidden folder. All right, so if I just wait for this to run. Now, just trying to think of dependencies. We're going to use TensorBoard to view the outputs of our model, the training, the progress towards it training and what have you. And so if we look in the README, you need to have installed TensorBoard on your system, and you need to issue from a terminal this command. to set up a TensorBoard server. And I'm wondering whether I can do that whilst we wait for the install. So I'm going to copy that code there. I'm going to go to a terminal here. And if I'm lucky, I can paste that line there and get TensorBoard up and running. Let's see if that works. And it doesn't work because my virtual environment's not up and running yet. That's why TensorBoard isn't installed. So I'm trying to get ahead of myself, which is somewhat silly. Yeah. I'll take a pause, and once the installation is done, we'll come back. I'm just realising I am able to pause. Well, a few more minutes have passed and a few seconds for you. It continued to install packages. There was a slight error at the end. I'm hoping that's not going to impede us. If I jump to the console, the virtual environment has been activated. So I should now be able to go to a terminal and run that TensorBoard command. And maybe I can't because sorry. There we go. That was just because when I first ran it, I hadn't installed TensorBoard. That's part of the requirements. .text. There we go. Now, once TensorBoard is up and running, it gives you a shortcut to a URL running locally on your machine. So we want to follow that link, control and click. I'm in positron here, so it says, well, how do you want to open that link? And we're going to do it in the default browser. And then in my web browser, we have TensorBoard available to us. Now, in the GitHub repo, I made sure some of the outputs of a previous run I had done were available. So even if you're unable to run any of the code due to issues in your personal setup on your PC, you should still be able to, I'd hope, do what I've just done and see runs I've done previously and get to see some of the outputs from the models. I know Sarah was particularly keen to see some of these SHAP outputs relating to her GRU models, and there they are available to see. All right, but we would like to do more than that. We actually want to be able to create these ourselves. So let's get back to POSIT. So let's recap. We've locally we've cloned the repo to our local machine. We are in a IDE with Python set up and the virtual environment set up. So we've got all of the ingredients we need. We've got the recipe, we're in our kitchen, the oven's on to start cooking and running this code. Apologies for the analogy, but I hope it in some way works for you. So let's pick some code and see if we can run it. So what am I going to, which one shall we do first? I think I'll start off with the gated recurrent units. It's somewhat shorter code. So if I open that up, you'll see a Jupyter notebook that we're sort of used to. I guess I can just run the whole thing and we'll see it go through its thing. So let's do that. Just pausing to think, is that sensible? Yeah, I think I'll do that. We'll get it to run and I'll go through, I'll step by step go through and probably explain some of the extra things here. Let's talk about what it's doing. Let's go run all and it will just run each step. So you see it's running this step here. These are all of the dependencies, package dependencies. Pandas, NumPy are fairly obvious. Matplotlib for plotting, time and dates. Torch for running the PyTorch models. sklearn is used for the pipeline approach that Jacky developed with TabNet regressor. So that's important. And then you'll notice a number of local imports. So one of the key things I've done is try and remove code and functions from these notebooks. If there is code or functions that are reused, I've tried to put them into centralized utilities. So there's a utils folder with lots of scripts, and those scripts have in them useful functions that are probably common to the machine learning pipeline, things that we'd like to centralize and put into software. Okay, so you'll see a lot of things here. There's the ability to read config files. So rather than having code that sets constants and minor variables, they can be put into a YAML config file and read from there. That helps you build software, make it automatable, put it into a software product, for example, and not need to code. I'm thinking ahead. We've got utilities relating to the neural network builds, the specific structure of the tabular neural network, regressor, Sarah's basic log, GRU, etc. I've got some data engineering scripts. They're a bit messy at the moment. They're specific to some of the data sets, but that's a step along the right direction and can get better in due course. There's some utilities to log things to TensorBoard, in particular the SHAP. There are some of the enhanced outputs. And I also think it's useful to output stuff to Excel. I find lots of people have Excel and they're used to looking at things in Excel, so you'll see we do that in this as well. You'll also see lots of stuff's been going on the right-hand side, so it's obviously ahead of us. So the gist of this is first of all, we read in the configuration files. Now, config files are here, all right? And so I'm saying I want you to use this GRU NJC config file. It's a YAML. You're going to just read the YAML and create a config. All right, so we could almost look at it. It's YAML file. It's got keys and key and value pairs, and they can be nested. So this gets read into dictionaries that can then be utilized. We jump back to our code, we read it in. I'm setting up a few things about random number seeds and timestamps and labels for our experiments, so that when we look in TensorBoard, we know which experiment we've run and its timestamp. We are setting up the log, the Excel log, giving it a name based on things, so we can go and have a look at that later on. Right. Then we can load the data. Now in this case, I'm using the payments data, and we're doing that the payments data from Splice. I probably got the wrong name using the old one. But, the standard data set that was in both Jacky and Sarah's code, but we're just using payments in both of these notebooks, so that we get some comparability, or in theory get some comparability. So that data gets loaded. The data file is in the config file. So you'll see the data directory is a URL, and it says what file name it is and various other bits, and there's code to work out what to do with those. All right. That data gets processed according to some routines that are in here, and then we save that out. Various bits to create train and test splits, common stuff. They get stored out so that you can go and have a look at them as well. Right. And we move on. Pipeline setups. This is a scikit-learn pipeline. And so we're setting up the data processing, pre-processing that we would want to do. When you're modeling on neural networks, you often have to standardize the data set and do some pre-processing as opposed to use the raw data. So that's going on there. And the pipeline does various things, keep columns, pre-process, and turn them into, because we're doing sequence models, 3D tensors. There's a time element to them. so the 3D tensor, and then we can use the tabnet regressor, but with a GRU in it. So that's set up as per Sarah's code. And having set that up, you can then define how to train the model and call that model training. And we see as it trained, I've added functionality to initialize SHAPs and output the SHAPs to TensorBoard. So you'll see over here the explanation to start up TensorBoard as we did a little while ago. This has run already, and you can see SHAP outputs. We should be able to go and see that run. If we go back to TensorBoard, there should now be a new experiment that's been run. So I just refresh. Right, we're doing the GRU, and the principle here is I've got my initials, a date, and a timestamp. So it is 10:15 when I ran that, 10:20 now. So this is the one that's just been created. So let's go and have a look at what's in there. And Sarah will be familiar with this. There's lots of outputs that she's chosen to log. So you get A versus E's. But there should also be some SHAP outputs. So we've got some final SHAPs from the models. In my SHAP analysis, I've done feature importance. You can just get the bar plot one, or you can do the B swarm, which allows you to see roughly the effect of each model. But in addition, I've done for the top features partial dependency plots, which can be very informative. I've also done an example of a single feature waterfall plot. So it shows how for one row in the data, how you get the prediction for that row, or how it's built up. Just examples of the sorts of things that can be done. Okay, so that's been produced. Let's get back to the code. I've generally followed the flow of Sarah's notebook from here on in, showing the same sorts of AVE plots that we've just seen were logged to TensorBoard as well. I've got a routine that creates the plot, and where I put writer, it will write it to the log, to the TensorBoard log. Right, so those are the same files that Sarah should be familiar with. Diagnostic plots. No, that was on the trained data, not particularly useful. You can do the same sort of thing on the test. That's more useful. Let's see what happens. There we go. And then you can look at actual and tests. Well, A versus E on both the train and test data sets to test one that's more informative by occurrence period here, or by development period here. These were plots that Sarah had created for her, so I've made sure they are largely reproduced. All right, so that has just run successfully. Hopefully you get the idea. And hopefully you'll also pick up that this code is a bit shorter. The notebook is a bit shorter than it would otherwise have been. That's going to be a bit more obvious when we jump out to the neural network versus GBM code. So let's move on to that and run that. Where I don't believe I did make any changes. I won't change them. Let's go and pick up Jacky and David's notebooks, or my variant of it. David had added in SHAP to this, which was very aligned to what I had done. So what I've done is take those SHAP exhibits and put them in the use the tools I've written for Sarah to recreate the SHAP exhibits that David had created. So I've tried to keep this notebook largely the same as David's. I've even kept some Italian descriptions in there. save me looking up on Google what they are in English. So I've tried to keep it the same, but there are some changes that are worth noting. I think originally David was using incurred and outstandings. Sarah was only using paids. So I've dropped the outstandings and case reserves as features in this model, which does degrade the quality of the model, but the theory was it might make it more comparable to Sarah's approach, and that might be helpful. Turns out it doesn't really make it comparable because Sarah's doing a square triangle, so to speak, whereas David's using triangles. That will mean something to working party members that are close to this code and have seen Sarah's video. It'll be meaningless to anybody else, I imagine. Let's get this running, and we'll follow it as it runs. Very similar sort of start, imports packages. This notebook is a comparison of a chain ladder to a GBM to a feed-forward neural network. I've chosen to reuse the chain ladder package as opposed to do the chain ladder from first principles. So we'll see that coming along later on. It's got its own configuration settings again, similar sort of idea. Here are those configuration settings. Got a number of options to make sure stuff plots correctly and random numbers and what have you, names of files. A little bit of talking about the data. The data needs to be processed a slightly different way, I think. Yes, I've had to write a special Davide processing function. Terrible of me. But there, that's done. And then, yes, we do a chain ladder. So this chain ladder, like I said, I've used the chain ladder package. It's a very good package, so make use of that. So I've taken our 40 by 40 triangles and mocked up the 42 occurrence quarters with dates, as you can see there. All right, so that's a data set. And the benefit of that chain ladder package is it can use an sklearn pipeline. So that's exactly what we're doing. So it becomes very easy to fit a chain ladder, literally 2 lines of code. And there you get some ultimates, and they're equivalent to the ones that were in the previous notebook. Then we're jumping back to getting ready for ML techniques in both for neural networks and potential GBMs, where we want to augment the data. So there's a familiar to David and Jacky backdate balance and backdated balances, pinning the tail. It's all familiar stuff. And then a claimed sampler. So I've tried to keep true to that, minimizing that changes. Then we get to the feed forward neural network, where we're keeping again the principles of the original notebook with the rolling origin validation and the hyperparameter tuning. So possibly a few minor changes to code here around the pipelines and the login centralized functions. I have struggled to log in the CV training because of issues between sklearn and the TensorBoard writer object. Serialization of things are going wrong. That's outside my control, so I've turned that off. Turn SHAP login off on the CV training is what we mean. So you get your CV results, you can see which is your best model, and then you can refit on. Sorry, I said what's your best model, what's your best number of epochs, or what have you, and various other parameters, and then you can refit having found those in a safe CV way on a larger proportion of the data. And it's writing out when it does that to TensorBoard. And you can see that here it says you see evidence of it writing out SHAPs. So let's go back and go back to TensorBoard in our browser. And if I refresh again, we should now see a new feed-forward neural network. Yes, there's a new one of those. So this is 20 past 10. So that's what I want to see. And various AVE plots, RMSE plots, where, yep, okay, good. So fairly standard log plots, but we also have the SHAPs again. So similar sort of principle, partial dependency plots for each of the features, as well as the feature importance, B-swarm, equivalent of feature importance, and then an individual row's prediction in for good measure. Log 1 payment to prior period is the most important feature, so that's going to be one of these. I'm sorry the screen is so small. Log 1 payment to prior period is the most important feature, so I should be able to look at that in bigger. As ever, it never wants to work, does it? I'm sure you can look at that in a slightly bigger way and see that what it's basically saying is the bigger the value of payment to prior period, the bigger the ultimate, I presume, is what we're doing there. Anyhow, with evidence there running and being produced, let's get back to the notebook, which from here on in should be fairly similar to the way it was. So oh, there's an error, look. I've left an error in the code. Damn. Oh, that's so annoying, isn't it? I'll have to fix that. I'll probably just fix that. I'll probably release this video and fix that post, because it's probably not the end of the world if that's given an error. But I wonder if it's causing anything else to error out. No, it's not. Okay, so I've got a minor error there, presuming that these ran. The code continues then to build a gradient boosting model, a GBM, and then one produces SHAP explanations for both the GBM and the neural network. I just want to check that they've been produced. They have. Right, so we've got the SHAP values for the neural network, and we should have something similar for the GBM. So they've been produced. They should be consistent with the outputs in the TensorFlow, in the TensorBoard. There we go. I've added a little bit about individual predictions, so you can. The GBM and the neural network, to cut to the chase, they have different opinions on what's important, but they still get to very similar sorts of predictions, and that doesn't surprise me. I don't think it necessarily means much other than you've probably got correlated input features, and I say that a little bit in here, but it's nice to see these sorts of features so you can start to think about those things and gain a greater understanding. The notebook continues to do a summary of the GLM, GBM, and neural network outputs. This is again familiar code, I imagine, for Jacky and David. I think I might have shortened it a little bit down here just to do it on the RMSE metric instead of doing RMSE and mean absolute error percentages or absolute error percentages. But there you go, there it is. So hopefully you can try yourselves pulling this code to your local machine, running it on your own version of Python in your chosen IDE, and hopefully that will work for you too. And if it does, it's an experimentation. It's a point where you can start to experiment and tweak and join the others of us that have been doing similarly. And hopefully collectively we can go on and do bigger and better things in a shared manner and enhance our joint knowledge. Okay, I hope that's been useful. Reach out to me If there are any issues, easy to get to me, I guess, over here on the collaborate part of the Institute's website. If you can't get to that, then you've got my email address and we can catch up that way. I'll stop there. Thanks very much for listening if you still are. And catch you soon. Bye.